In this video, we will be discussing naming of ionic compounds. And there are 4 different groups of ionic compounds that all have slightly different naming rules. And on your comprehensive guide to chemical naming, they are naming rules numbers 1 through 4 that we will be going through in this video. So let's start out with number 1. So naming rule number 1 is for simple binary ionic compounds. Simple binary ionic compounds. And when I say a simple binary ionic compound, I mean a compound that contains a metal, and that metal is a main group metal, and then that it only contains 2 types of elements, 2 element types. When we name simple binary ionic compounds, we simply take the name of the metal. So it's the metal name, and that stays exactly as it is. And then we take the root word for the non-metal and change the ending to IDE. So the non-metal root with ending in "ide". And you've seen these before when you were writing chemical formulas: potassium, bromide, lithium, chloride. They all have the similar sound. And so one of the best ways to practice chemical naming is just by reading a list of chemical names so you get used to hearing the language and it sounds correct. But let's do a real quick couple of examples of this. So example 1, we have KCl. So K is potassium. It's a main group metal, and there are only 2 element types here, so this is a simple binary ionic compound. And so we're just going to take the name of the metal, potassium, and then we're going to take the root of the word chlorine, take the root of this, we're going to change the ending to IDE. So instead of putting potassium chlorine, we change it to chloride, potassium chloride. So there's one example, and then on example number 2, let's do CaO. So once again, calcium is a main group metal, and there's only 2 element types here. So we take the name of the metal, calcium, and then we're going to take the root of oxygen, which is kind of a strange one. It's just ox. The egen goes away, and we change the ending to IDE, calcium oxide. So that's our first naming rule. Next up, let's talk about group number 2, which is binary ionic with a transition metal. Binary ionic with a transition metal. Ran out of room there. Binary ionic with a transition metal. So here we still have a metal, but this time instead of it being a main group, it's a transition metal. And then we still only have 2 element types. So that's how we classify whether something is binary ionic with a transition metal. And here we still start by taking the metal name, the name of our metal, but we also have to indicate what our charge is for transition metals, because they don't always have the same charge. So we're going to take the metal name, and we're going to indicate our charge with a Roman numeral. So we're going to indicate charge in parentheses, as a Roman numeral. And then we are still going to take the non-metal root that ends in "ide." and change that ending to IDE. So really the only difference here is that we have to put the charge in parentheses as a Roman numeral, because unlike with a main group metal, if you have a transition metal, there can be more than one oxidation state. So our naming rule has to account for that and show what oxidation state we are talking about. So let's do an example and talk about how we figure out what the charge of our transition metal is, because that's not immediately clear to some of us. So if we have T titanium TiF4, so titanium is our transition metal here, but we don't necessarily know what oxidation state titanium is in. So to figure this out, we kind of do our crisscross method, but backwards. We need to figure out the total amount of negative charge that exists in this compound, and then balance it with an equivalent amount of positive charge on our titanium. So fluorine, if we look at our periodic table, it's in group 17, so it has a -1 charge. If we just had one fluorine, there would be a total negative charge of just -1. But we don't just have one fluorine here, we have 4 fluorines. So that's 4 -1 charges. So we also need 4 positive charges to balance that out. 4 +1 charges to balance those -1 charges. And since there's only one titanium atom here, all 4 of those positive charges must come from that titanium. That means that the titanium must have a charge of +4. So when we write our name, we have to indicate that charge. So we're going to start out with our metal name, titanium. And then we need to indicate that charge with a Roman numeral in parentheses. So I'm going to open my parentheses. Roman numeral 4 is IV. Close my parentheses, and then I'm going to put the root of the nonmetal ending in "ide." So instead of putting fluorine, I'm going to change that to fluoride. Fluoride. Titanium 4 fluoride is how we read that off. So let's do one more example of that. Example number 2. We will do manganese MnO2. So here, manganese is a transition metal, so we need to determine the total amount of negative charge and then balance it with the correct amount of positive charge. So we have oxygen. If you look for oxygen on the periodic table, it's in group 16 and it has a -2 charge. But we don't just have one oxygen, we have 2 oxygens here. So we have 2 -2 charges. So we need a total, we have total negative charge of -4, so we need to balance that with 4 positive charges. Because there's only one manganese here, all 4 of those positive charges have to go on that one manganese. So we know that manganese has an oxidation state of +4. So when we write our name, we're going to put manganese, and then in parentheses, once again, is the Roman numeral IV, which is 4. And then, instead of putting oxygen, we change that ending to IDE, oxide. So our third class of compounds are ternary ionic compounds. Number 3, ternary ionic. And the way that you know that you have a ternary ionic compound is if you have a metal, and that metal is a main group metal, and then you have more than 2 types of elements. And when we have a ternary ionic compound, the first part of our ternary ionic can either be a metal or it could be a polyatomic cation. Usually it's going to be a metal, and once again you just put the metal name, the name of the metal, metal name, and occasionally it might be the name of the polyatomic. polyatomic ion. And then the second part of our ternary ionic compound is almost always just going to be the name of a polyatomic ion. Name of polyatomic. And there are a couple maybe rare scenarios where this won't be true, but generally speaking, it's always going to be the name of a polyatomic ion. So let's try an example of this. So example 1, we have KClO3. So we know this is ternary ionic because potassium is a metal and it's a main group metal. And then we have more than 2 types of elements because we have potassium, chlorine, and oxygen. So we're going to take first our name of our metal, so potassium, and then we just need to figure out the name of this polyatomic ion. And this is the chlorate ion, ClO3, -1 is its charge, but that doesn't actually matter here. So this is potassium chlorate. And then one more example. We have NH4ClO3. So here we actually have 2 polyatomic ions. We have NH4, which is a polyatomic cation, meaning it has a positive charge, and we have once again the chlorate ion, which has a negative charge. So here, this is where we have first a name of the polyatomic, and then also just connected to the other name of the polyatomic. So NH4 with a +1 charge is the ammonium ion. Ammonium. And then ClO3 is the chlorate ion. So we're just putting the 2 names of the polyatomic ions together. So this is ammonium chlorate. This is its full chemical name. Our last group of compounds are ternary ionic compounds that also contain a transition metal. So group number 4 are ternary ionic with a transition metal. With a transition metal. And the way that you'll know that you have a ternary ionic with a transition metal is you have a metal to start, and then it's, instead of it being a main group metal, it's a transition metal. And then you have more than 2 types of elements. And then when we name ternary ionic compounds that contain transition metals, we follow the same rules as we do with ternary ionics, but then we also have to add in that charge in Roman numerals in the parentheses in the middle. So this would be the metal name, plus our charge of our metal, as Roman numeral, and in parentheses, the C's, and then last but not least, we add the polyatomic name. Alright, let's do a couple of examples. So our first example number 1, is Mn and then C2H3O2. So here we have manganese, which is a metal, it's a transition metal, and there's more than 2 types of elements. In fact, there are 4 types of elements in this chemical formula. So I'm going to start by writing the name of the metal, manganese. And then I have to use my reverse crisscross method to figure out, oh, and I have 2 acetates here. I actually wrote that incorrectly, but that's okay. We'll fix that now. But I still need to use my reverse crisscross method to figure out what the charge on manganese is. And so C2H3O2, that is the acetate ion, and acetate has a -1 charge. So C2H3O2, the whole thing has a -1 charge. But I don't just have one acetate here, I have two acetates here. So I have two C2H3O2 with a -1 charge. So my total amount of negative charge is -2. And there's only one manganese to balance that charge out. And I know I need +2 to balance that out. And all that +2 charge is going to go on that one manganese. So manganese is going to have a charge of +2. Which I show with II, Roman numeral 2, in parentheses. And then last but not least, I just put the name of the polyatomic, which is acetate. And then our final example, example number 2 here, is going to be MN2, and then PO4, 2. So here, once again, we have manganese. I'm going to write my name of my metal. And then I have two PO4 ions. So PO4 is the phosphate ion, PO4, and it has a 3- charge, a -3 charge. But I don't just have one of those, I have two PO4s with a 3- charge, which gives me a total negative charge of -6. So I know I need +6 to balance that out, and since there's only one manganese, it all has to go on that one manganese. So this is going to be manganese 6, so that's Vi as a Roman numeral, and then I'm just going to put the name of the polyatomic ion, which is phosphate. Phosphate.